The rail vehicle moves steadily, while onboard systems monitor alignment during automated assembly operations. The completed train moves steadily, while onboard systems monitor performance before high-speed testing begins.
High-grade aluminum billets are positioned for thermal conditioning to prepare structural materials for high-speed rail manufacturing.
Ultrasonic inspection identifies internal material defects before structural processing begins in the rail manufacturing sequence.
Uniformly conditioned billets now advance toward the structural extrusion phase of high-speed train manufacturing.
Heated aluminum billets are forced through precision dies to create complex multi-hollow structural profiles for the carbody frame. Massive hydraulic pressure ensures the consistent wall thickness of the aluminum profiles required for high-speed railway structural integrity. These precision-engineered aluminum extrusions are now standardized and cooled, providing the essential components for the primary car body assembly.
この奥を見てくださいよ。見えますね。
問題ありませんね。
A rotating friction stir tool forges adjacent aluminum extrusions together, forming a continuous solid-state structural seam. Ultrasonic inspection verifies internal weld integrity, confirming the friction stir seam meets structural tolerance requirements. Individual aluminum extrusions are now fused into unified monocoque structural panels through continuous friction stir welding seams. These welded aluminum panels now meet structural tolerances and are prepared for controlled integration into the primary train body structure. Structural module integration forms the rigid aluminum framework for the future high-speed rail vehicle body. hydraulic frames align curved aluminum panels to form the structural cylindrical shell of the rail vehicle body. Structural modules form the rigid aluminum framework for the future Shinkansen vehicle body. The Shinkansen 500 series nose begins with precise alignment of tapered aluminum bulkheads and skeletal ring frames.
よっしー、問題ないよ。了解しましたね、先輩。
Laser metrology verifies the aerodynamic taper geometry of the Shinkansen 500 series nose structure.
The alignment looks correct based on the laser reading.
Yes, the data confirms the placement.
Multi-axis CNC machining refines the structural bulkhead, supporting the extreme aerodynamic taper of the nose.
Laser inspection verifies the precise aerodynamic taper of the Shinkansen 500 series nose frame.
Forged steel Bogey frames are milled for Shinkansen trains, built to run at 300 kilometers per hour.
Automated torque systems secure primary suspension components and axle boxes to ensure maximum stability and vibration damping.
This この鈴勝ちでお願い出ますね。
はい、確認しました。不定トルクに倒しました。協力しますで。
The high-speed Bogey units are now fully assembled and verified for dynamic load testing before vehicle integration.
Synchronized lifting systems raise the aluminum car body shell to prepare for integration with the high-speed Bogey units.
Laser alignment guides the car body during the final descent to the Bogey pivot interface.
Torque sequence complete on position 4.
Confirmed. Data matches specifications.
The structural marriage is complete, and the rail vehicle can now move through the factory for systems installation.
Copper wiring harnesses are routed through the aluminum carbide shell to establish the primary electrical architecture.
Diagnostic testing verifies electrical continuity across the distributed control processors inside the train control network. The internal wiring network is now fully routed and prepared for integration with external power collection systems. Specialized overhead cranes position recessed base plates to integrate the high-voltage power collection system within the aerodynamic roof. Technical teams secure the folded wing-type pantograph into its recessed bay to maintain a smooth aerodynamic profile at high speeds.
Okay, bring it down slowly. Watch the clearance on the left. Copy that, steady now.
The roof system integration is complete with all high-voltage hardware and aerodynamic fairings secured for final industrial coating.
The completed train moves onto the engineering track to begin final high-speed operational testing. The rail vehicle maintains stable motion while onboard systems continue controlled high-speed testing.
NextGen Machine Works, building the impossible. Subscribe to join the future.